Hey guys, welcome back to another RESK Maths video, and in this video I'm going to be talking about a very interesting technique which you can use to solve equations such as the one you see here. And it's not really an equation, more a question, but these kind of questions. So it's a counting question, and basically it's asking you for how many ways you can solve the equation above with 5 unknowns all adding up to 100. So obviously when you first see this question, it's a bit weird, like how would you possibly do this? Like, you can think of one, or like you can think of loads of solutions, obviously. Like maybe one solution could be they all equal to 20, so I'll just write A, B, C, D, E is all equal to 20. Maybe that's one solution, and yeah, that would work. And you might try and do something like set A to 1 and then set B to 1, set all of them to 1, and then try and find there's like going to be 95 different ways to do D and E, and then try and do something like that. But that's not really going to work in the long run. It's going to get too complicated too quickly, and you're not going to be able to understand it. So I'm going to show you guys a really interesting method which is called the star and bar method. So I'll just call it star and bar. So yeah, now the way we do this is, let me just focus on a smaller question first, just so we can actually show it a lot easier. So let's focus on a question A plus B plus C, and let's just say it's 10. So it's just a smaller version of the question above, right? So basically what we can do is we can give a dot. I'm not going to try and draw stars because that would be a bit too time consuming, but pretend each one of these circles is a star, just so it looks nicer. So let's draw 10 stars, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's our 10 stars, and if we say each star represents 1, so when you add up all of these, you're going to get 10, like so. So this is an effective representation of the number 10. Now what we can do is we can actually put in these bars, right? So let's just say I put in a bar here and a bar here. There we go. So what have we done? Well, we've actually just split this group of 10 stars into 3 different groups, 3 different smaller groups. So we've got one group here, one group here, and one group here. And if you haven't already noticed, these groups actually correlate to our A, B, and C variables. So we can have A, B, and C, like so. So by putting in 2 bars, we've been able to split up this group of 10 stars into 3 smaller groups, and each one of those groups represents a variable, so A, B, and C. In this case, the solution comes out to be, well, A is 3, B is going to be 4, and C is 3. And you can see we're never going to go over 10 because we're not changing how many stars we have, we're just putting in bars. And this is going to give us a perfect solution every single time. So it really just becomes a question of permutations. So now this is the thing which you really want to work out. It's how many permutations of this order, how many unique permutations are there that correspond to this system, since each unique permutation is actually a unique solution. So we just want to find the total number of unique permutations. Okay, so now we can actually use permutations and all that stuff. So now what I'm going to do is I'm going to change around this a little bit just so we can understand it a bit better. So what I'm going to do is I'm going to write zeros as stars and 1 is a bar, just so we're left with a number or a string, and it's a lot easier for us to work with. So let me just put in 0, 0, 0. We'll just put 1 there, 0, 0, 0, 1, and we'll just put in like that. Okay, so to work out the total number of permutations, you might already know a formula, but it's pretty simple because all we're going to do is we're going to work out the total permutations of this entire thing, and then we divide it by the total permutations of just number of yellows. Number of stars. So what that means in practice is there's 10 stars. Let me write that here. So we got 10 stars and we have 2 bars. And what we can do is we can write, so we have total, but this is not unique. So total non-unique permutations. And this is a really easy formula. It's literally just going to be the total length of this string. So that's going to be 12 factorial. Because if you know how it works, you select one, then you have 11 to pick from, so you just pick another one, and it just continues until you've used up all of them. So that's where the 12 factorial comes from. And we basically want to work out, for each of those 12 factorial permutations, we want to work out the different permutations of the stars and the bars. Since if you're just going to move around, like let's say if we just swap these two, that's going to be counted as another permutation, but it's not actually going to be another unique solution. So we don't want to count those. So we're going to say the total, let's just say total permutations of stars. And this is just going to be the total ways you can arrange these 10 stars. So, well, that's just obviously going to be 10 factorial, isn't it? And then same kind of thing of bars, how many ways you can arrange the bars. Pretty simple, because there's only 2 ways. You can either put this one, or you can swap them. So if we assign 1 and 2 to this, right, we can put 2 first and then 1 here, or the other way around. So we're going to get 2 factorial. So therefore, we can now work out the total unique permutations. If we maybe do this in green, the total unique permutations is just going to be unique permutations. And this is literally just going to be the total non-unique permutations, 12 factorial, divided by, for each of those cases, 10 factorial multiplied by 2 factorial. Like so. And this actually comes out to, if you type this into your calculator, or just do it with a bit of simplification, just type it out now. This actually comes out to 66, like so. And obviously, you could actually do a bit of simplification on this, because it's not too difficult, but yeah, this was a really easy way of working out how many solutions there are to this equation. And now all we have to do is we have to generalize this. So for our equation up here, actually I'll just rewrite it over here. So here's our equation. A plus B plus C plus D plus E equals 100. So from this, we know there's going to be 100 stars, right? There will be 100 stars. And if we look at the example above, there were 3 variables, but we only needed 2 bars, because 1 bar splits the group in 2. So for each bar, you just add a new variable. So we need the number of variables minus 1 is how many bars we need. So in our case, with 5 variables, we're going to need 4 bars. And that's going to leave us with a sequence. If I just draw out a little bit of it here. So if we just had like this, a few more, and just like carrying on throughout this entire sequence, we're going to have 100 stars, 4 bars. So we're going to have a total length of 104. We'll just call it items. Like so. So now this question becomes really easy. What we can do is we can do the total permutations, which is just going to be, I'll do it over here. Total permutations. Well, since there's 104 items, this is just going to be 104 factorial. Okay? And then we've got the number of star permutations. So star permutations. And that's just going to be 100 factorial. And then if we do the bar permutations, I've been saying permutations so many times. The Bath permutations is simply just going to be 4 factorial because we're just taking the factorial of each of these numbers to find out the permutations, which gives us our solution, which we've been working towards, as the total unique permutations, because remember, each permutation is representing one unique solution. So total unique permutations is equal to, well, we've got 104 factorial over 100 factorial times 4 factorial. Because remember, we're going to find total permutations of a sequence, but we want to eliminate all the ones which aren't unique. So we're just going to eliminate the ones which you'll rearrange in stars and the ones which you just rearrange the bars, since all of those are unique. And that gives you this sum. If you try and type this directly into your calculator, you're not going to be able to do it, but with a bit of expanding, so if we just expand this a little bit, you'll see that this is the same as 100 factorial multiplied by these, and then we just get a bit of cancelling, so we write that like so. These two are going to cancel, which simply leaves us with this sum, 104 times 103 times 102 times 101 over 4 factorial. And this is actually something which we can work out. I'll just type it into my calculator right now. 102 times 101 over 4 factorial. And that comes out to 4598126. So there's our answer. This is about 4.6 million different ways of solving this equation. And I'm sure you can see now that if you try to do it using like regular counting techniques, like eliminating some variables and then doing it like that, you probably wouldn't be able to get an answer like this, because this is super precise. And yeah, this is like, it requires a special method, and this star and bar method can actually be used for a lot of other scenarios if you're creative enough, if that makes sense. But yeah, thanks for watching. I just wanted to share this really cool method of solving questions like this. Thanks for watching, and I'll see you guys in a future video. Bye.